All right, today we are going to work on adding and subtracting rational expressions, which just means adding and subtracting fractions. Now, whether you are adding or subtracting a fraction, you have to create, or you already have to have, a common denominator. Not necessary for multiplication and division, but definitely required for addition and subtraction. So if you don't already have a common denominator, meaning the denominators are the same, then you got to create one. So I try to think of the least amount of work possible that I would have to do for that situation. So I just have a couple examples with just plain numbers here. So 5 and 10, the smallest denominator both of those guys would go into would be 10. So to get a common denominator here, I would just need to take that first fraction. I'm multiplying it by 1, but I'm multiplying it of the format 2 over 2. So we're not changing the value of the expression, but we're changing that first fraction so it has a denominator of 10. So this would become 8/10. Those are equivalent. Once you have a common denominator, which then I do, you literally just add or subtract. This is going to be subtraction straight across the top. So 8 minus 3 is 5. Now you take and keep the denominator the same, so this should just remain 10, and then if your result is something that you can reduce, like 5 over 10, then you're totally allowed to do that. That would be 1/2. Now, in the second example I have here, there's nothing that I'm going to multiply 2 by to get 3 that's not a fraction itself, so I don't want to mess around with that. So there are situations where you might have to multiply both fractions to create a common denominator. So between 2 and 3, I think the smallest denominator I could think they'd both go into would be 6. So I'd just do 3 over 3, 2 over 2. The 1/2, this is the same as 3 over 6. And 1/3 is the same thing as 2/6. And then we're just going to add these guys up. 3 and 2 would give me 5 on the top, keep the 6 on the bottom, and 5 over 6 doesn't reduce. So we are done. Okay, now we're going to put some variables in the mix. Now, these two fractions I have here, actually all these fractions that are on the front side of these notes already have a common denominator. Before you subtract anything, what I might, and you don't have to write it specifically on the line, but restrictions, anything that would cause your denominator to be 0, those still exist when you're adding and subtracting. So just for this problem, the only thing that's going to cause you an issue to create a 0 denominator, because we can't divide by 0. So a being 0 would be the problem. That's it. So I'm going to write that on my restriction just before I even start the problem. Okay, now this is not a big deal. I have a common denominator. So do not change the denominator when you do this. It's just going to stay 3a. Across the top, you go ahead and combine like terms if you can. Here, 8 and 1 is just going to add up to 9. Now, once you're here, it's going to depend on the problem. I don't have any adding or subtracting. It's just product on the bottom and just a plain number on the top. You are allowed to simplify. So in this case, 9 divided by 3, sorry, I'm not trying to cover up the 3. 9 divided by 3 is 3. The a is still going to remain there, but you could simplify this to just be 3 over a as your answer. All right, now I'm just, same thing on this one. I'm going to do my restrictions first. 4x minus 3, I do not want that to be 0. So that's what's in the denominator for both of these fractions. I just kind of do it in my head and I think, okay, how would I solve this? I would add 3 and then I would divide by 4. So we don't want x here to be 3/4. And since that's the denominator for both, that's going to be your only restriction. You do not have to worry about the numerator. Okay, now I'm just going to copy the denominator here, 4x minus 3. If you have a subtraction problem, this is super tricky. So let me just, I'm going to grab a different color and I'm going to write this to the side. So across the top, I have 5x minus 1 and I am subtracting the other fraction. So here's the best thing I can tell you to do. If this has more than one term, which it does, just put that second numerator, or think about it, in parentheses, because you have to make sure you subtract both of those terms. So it's just like distributing a little -1. So I'm going to have 5x minus 1 minus the negative 7x is actually going to turn into plus 7x. Minus a positive 8 is minus 8. and then go ahead and combine like terms. So I'm just working on the numerator here. So 5x plus 7x is 12x, and -1 minus 8 is -9. So that's going to be my numerator. And then at this point, we don't want to cancel anything out because we have subtraction in both the numerator and denominator. But I'm going to throw back to what we've been doing the last couple of days. Just see if you could factor anything. So like 4x and 3, they don't have anything in common. I'm going to leave that alone. This one, 12x and 9, both of those guys are divisible by 3. So just the top of this, if I took a 3 out in front, 12 divided by 3 would be 4. That would have an x with it. -9 divided by 3 would be -3. This doesn't always happen, but it's going to happen on this problem. The bottom of this was the 4x minus 3. Okay, now, since I factored this, just took out a greatest common factor, and now on the top I have a product. Because I have a product, I'm multiplying two things together. It's in factored form. These are factors. We're multiplying. You can cross this off. That doesn't always happen. It does for this problem, apparently. So my answer would actually just be 3 for that question. That doesn't always happen, but it can. All right, for this next problem, maybe just a little piece of advice I would have you do before we start subtracting. Let me just factor everything in this problem. These two denominators are already common denominators, but let's just factor here really quick the bottom of that fraction so we can see what our restrictions would be. So multiply to get -20, add to get 1, we'd have x plus 5 and x minus 4 for both denominators. So just keep that in mind. So I can write my restrictions just right now would be -5 and +4. That would cause your denominator to be 0. So we have that. Now, what I would tell you to do, let's do the top just like we did the last question, because we already have a common denominator, so we're just going to subtract. So I'm going to have x squared plus 7x minus, and I'm just going to put this in parentheses, x squared minus 35. The reason I want to use parentheses, I don't want to forget to subtract all the terms, and if I put parentheses there, it helps me know that I need to distribute that little negative. So this is minus x squared minus a negative will actually turn this into plus 35. And so what's going to happen here, actually when I combine like terms, these guys cancel each other out. So I have 7x plus 35. That's going to be on the top of the fraction. And I'm just going to factor this just as I have it right here. These, I notice, are both divisible by 7. So I'm just going to write the factored form here. This would be 7 times x plus 5. Okay, so that's just me simplifying the numerator. So the numerator of that fraction, 7 times x plus 5. Now, factored the denominator at the beginning of the problem. So that was x plus 5, x minus 4. And remember, you only have to worry about restrictions for the bottom of the fraction. Anything that makes the denominator 0 totally doesn't matter if the numerator is 0. And if you'll notice, right in this problem, they have factored form on the top, so a product multiplied, factored form on the bottom, two things being multiplied. If any match, then you can cross them out, which happens here. And so my answer, we'd still have a 7 on the top and an x minus 4 in the bottom. And that's going to be my answer. These guys, we already wrote our restrictions. Okay, let me do the same thing here, one more of these. So multiply to get -12, add to get -1. I'm going to do -4, +3. That would be the factored form of the denominator for both of those. So I can do my restrictions right now. They both have a common denominator already. So 4 would be a problem here, -3. So those are going to be my two numbers we don't want x to have plugged in for them. And I'm just practicing with this again with you guys real quick. This will be a little bit different than the question we just did. But I'm just working on the numerator here. So I have x squared minus 6x. We are subtracting x minus 12 on the top of the second fraction. We'll keep the denominators the same there. So we get x squared minus 6x. Now this is going to be minus x. Minus a -12 is actually going to turn that into a plus 12. So I'm just going to combine like terms here. We get x squared minus 7x plus 12. And just while I'm here, this is going to be the numerator. So let me just go ahead and see if I can factor this. So if I can think of two numbers that multiply to give me 12, add to get me negative 7, and actually I can do that, negative 3 and negative 4. If you multiply negative 3 times negative 4, that gives you positive 12. And then if I add negative 3 and negative 4, that's negative 7. So that's the factored form of that. All right, so then let me put it back together. This is the numerator, x minus 3, x minus 4. And then our common denominator, which we factored at the beginning of the problem, x minus 4 and x plus 3. I have a product in the top, product in the bottom, so if anything matches, we're allowed to cross it out. So those guys match, we'll cross those out. Now, these guys are different. So I have x minus 3 and x plus 3. So those guys are just going to be left for our answer. So x minus 3, x plus 3. Don't cross those x's out. You can't do that. You don't have products anymore. We have subtraction in the top, addition in the bottom. That should be our answer. We took care of our restrictions at the beginning, so we should be done. And I have one more here on the back. These guys already have a common denominator. And for this problem, there's nothing to factor for that denominator because it's just a plain x minus 1, so there's no factoring involved. So what I'm going to do here, I'm just going to write it underneath. I'm going to take the numerator. For this problem, we are adding. So literally, I'm just going to copy that, combine like terms. So we're going to get x squared, 4x and 2x would be 6x, and then minus 7. That would be the top of that fraction. And if I can, let me see if we can factor this just while we're sitting here. Oh, actually, hang on. Let me go back. I forgot. Let me do the restriction. Just from the original problem, you just have x minus 1 in the denominator. So positive 1 would be our only restriction here. X can't be 1. That's the only restriction you have because that would cause that original denominator to be 0. Sorry, I forgot to do that when I started. Now here, multiply to get negative 7, add to get 6. We can do this. I'm going to do x plus 7 and x minus 1, because if I do 7 times negative 1, that's negative 7. 7 plus a negative 1 would be the 6. So that's the top. Now, let me back up here and just put it all together. So the top of the fraction, combine like terms, and then I put it in factored form so we could see if anything would cancel. The bottom was x minus 1. That was the common denominator. So that's actually going to be able to cancel here because I have a product on the top and I just have that one term on the bottom. So if they match, we can go get it to go away. So the whole fraction actually cancels out here, and just x plus 7 would be my answer. And then just remember, even though this canceled out, you still have to put that 1 as part of the restrictions. And it's because of the bottom of the fraction, not the top. But you have to include restrictions even if you cancel things out. Okay, now the rest of these are going to be a little trickier because we're going to have to create common denominators. And they don't have common denominators. And I have to have you look at this very first question. I'm going to just kind of slide down to the bottom here. I'm just going to immediately write restrictions, just looking at the problem. So here, x plus 9, negative 9 would cause you a problem. That would make that 0. And if you just have a plain x, then 0 would plug in to cause you to divide by 0 there. Okay, now here's the thing you have to remember, and this is what people screw up. You have to get a common denominator before you can add these. So I obviously don't have that here. I have an x plus 9 and I have an x. When you create a common denominator, you have to multiply your fraction by 1. You cannot just go, oh, here's an x, and I'm just going to add 9 to the top and the bottom. You cannot add things. It has to be multiplication. So I know this is a little bit tricky, but to make these match, this one is going to need I just want you to think about this like it's in parentheses. Okay, so I can't add something. I need an x here, though. So I need an x on the top and the bottom. You cannot add things. It has to be multiplication by 1. 1 is just going to be in the format like I have here, something over itself. So here, you're going to have to multiply top and bottom by that x plus 9. It has to have both of those p's. You can't just add things. It has to be multiplication by something over itself. Now, we're going to simplify here just on the top. So this would just be 3x, and my common denominator, we can just leave it in factored form. That's totally fine. That actually will probably make it easier. So let's just leave the bottom in factored form. Okay, now when I do the top though, I am going to do a little distributive property here because we're going to simplify the top when we add these fractions together. So if I take and multiply 3 there, we're going to get 3x plus 27. Okay, we've got this common denominator, x times x plus 9. All right, now if I just work on adding the numerator together, just going to combine like terms. So 3x and 3x would be 6x. There's nothing for me to combine that 27 with, so I'm going to leave that alone. Now, just to check, and like I said, not always, but on the top here, both of those numbers are divisible by 3. So if I took a 3 out in front, left over, I'd have 2x plus 9. Now, in this particular problem, that is not going to cancel anything, but I just want to check and make sure that if I were to factor something, that it doesn't match up with the factor on the bottom. So this actually is going to be my answer, and just go ahead and leave it in the factored form. So just leave the parentheses there at the end of the problem. Okay, now this guy. This is not a proportion, right? We're not solving anything, we're simplifying. We're going to add these guys together. So this has an x minus 4, this has an x plus 2. Cannot add and subtract things, it has to be multiplication. So just think about this as being in a little set of parentheses. This side is missing an x plus 2, and this one is missing an x minus 4. Now, I'm going to go ahead, let me write the restrictions there. -2 and +4. We don't want either one of those numbers for x in this example, so we'll just write that out to start. Now, I'm going to leave the denominator in factored form, but I am going to simplify the numerator so that way we can see if anything cancels. So the first fraction, you'd have 2 times x, so it'd be 2x, plus 2 times 2 is 4. That's just the top of that fraction. The top of this fraction, I'd distribute a 3, so I'd have 3x, and then 3 times -4 would be -12. This is just the top of the fraction. I'm going to combine like terms here. So 2x and 3x would be 5x. 4 minus 12 would be -8. Nothing there is going to factor. 5 and 8 don't have anything in common. So this is just the top of the fraction. The bottom of the fraction, that common denominator, was x plus 2 times x minus 4, and nothing is going to cancel there, so this is going to be my answer, and we already wrote down the restrictions. Nothing else is going to get crossed out. Okay, now the 2 at the bottom. If you don't have factored form in your denominator, I'm going to do that first to see what, if anything, I need to create a common denominator. Okay, so I have 5x and 10 in the bottom here. Both of those are divisible by 5. So if I take that greatest common factor out in front, the bottom of that fraction would look like 5 times x plus 2. We're going to subtract here. I got 6. Now both of these guys, 12 and 24, are both divisible by 12. This is going to need an x plus 2. Okay, now for us here, this is nice, because this has an x plus 2, this has an x plus 2. So I'm not going to need to mess around with variables on this particular problem. But to make these match, this one has a 5 and this one does not. So I'm going to need a 5, top and bottom. This one has a 12, this one does not. So I'm going to need a 12, top and bottom here. Now, when I do this, I'm literally just going to multiply. So 12 times 4 is 48 on the top, and 12 times 5 is 60. Go ahead and leave this in factored form. For this problem, or this fraction, 6 times 5 is 30. That would go on the top, And I can do the same thing here. 12 times 5, this will make the denominators match. Just go ahead, leave it in factored form. All we're going to do is subtract the two numbers on the top. So 48 minus 30 would be 18 over 60 times x plus 2. And then totally up to you how you want to do this, but we're not going to do anything with this set of parentheses, but I do have a product on the bottom here. So I can reduce this 18 over 60. Both of those numbers are divisible. Let's see, both of those numbers are divisible by 6 is the biggest number that'll go into both. 18 divided by 6 is 3. 60 divided by 6 is 10. And we're just going to need to keep that x plus 2. And again, go ahead, just leave that in factored form. If it's in factored form, it's so much easier to see the restriction. So the only problem number in this question, because we really didn't cancel anything out, we just reduced and did some factoring, would be -2. That would be my problem there. So we don't want x to be -2. That'd be our restriction for that question. And we got one more here. So I'm going to factor first the denominator, see what we're missing. So x squared minus 9, that's a difference of squares. So multiply to get -9 and add to get 0, x plus 3, x minus 3. That's just the denominator of that one. The denominator here, multiply to get -6 and add to get 1 would be an x plus 3 and an x minus 2. So I'm just factoring the bottom of each of those. Sorry, I should have written that a little bit more similar to what I did on the last question, but just the factored form of each denominator. So in factored form, we have 2x, we have x plus 3, x minus 3. And on this one, we have 5 over x plus 3 and x minus 2. All right, now I already have an x plus 3 in both of these. So we're on the right track to getting a common denominator. What I'm missing over here is the x minus 3. And this one has an x minus 2, so that's what I'm missing over here. So I'm going to do x minus 2. Now, don't do anything to the bottom of this fraction, okay? We got a common denominator. They don't have to all come in the same order when you write them, as long as you have all three of the same factors. What I am going to do, though, is I'm going to simplify the top of this. So just a little distributive property, these are being added. So just right now, just like a little sidebar, I'm working just on the top. This guy would become 2x squared. So 2x times x, that's where I'm getting that. 2x times -2 would be minus 4x. And I'm adding to that, 5 times x would be 5x. And 5 times -3 would be -15. So we're going to get 2x squared. Combine these guys here. Let's see, what would that be? That'd be plus just 1x and then minus 15. So I'm going to see if I can factor this. All right, so if you like the factor by grouping, we're going to multiply first and last 2 times -15, which is going to give me -30. And we're going to add to get the number in the middle, which is 1. The only two numbers that are going to fit both of those requirements, I'm going to do -5 and 6. -5 and 6 multiplied is -30. -5 plus 6 is 1, so we should be good there. I'm going to use that to break apart that middle term. So I get 2x squared. I'll just do the plus 6x first, and I'll do the minus 5x second. That really doesn't matter, but just for this example. Okay, to factor this, you're going to go straight down the middle. And the first two terms, see what those have in common. So 2x squared and 6x, 2 and an x. If I divide that out of both of those terms, you'd have x plus 3. Now this is a little tricky. If both of these terms on the other side here, see how they're both negative? I'm going to take out, both of them are divisible by 5, I'm going to take out a -5. If they're both negative, take out a negative. And then left over, that would just be a plain x. Negative 15 divided by negative 5 would be 3. And then if we've done this correctly, what happens, these two match. And so that's going to be, I'm going to just pull that out of both terms, x plus 3. And the leftover is your other factor. So what you had out in front, the 2x and the minus 5. Okay, now I'm really sorry. I probably should have given us some more space for this problem. So here's what we have. That is the top of the fraction. Let me grab another color. All right, so we have x plus 3. We have 2x minus 5. Our common denominator, once we created that, we had x minus 2, x plus 3, and x minus 3. It doesn't have to be written in a particular order. And then in this particular problem, I can actually cancel a set of factors here, but I am going to leave this in factored form. So my answer, what we'd have left on the top, 2x minus 5. On the bottom, just leave it in factored form. So just leave the parentheses, x minus 2, x minus 3. And then your restrictions, sorry, I should have done that up in the original. When we had our common denominator, you're going to have positive 2 is a problem here, negative 3 is a problem here, and positive 3 is a problem here. So we'd have 3 restrictions. X can't be 2, negative 3, or 3. And our answer was that 2x minus 5 over x minus 2, x minus 3.